Hi, welcome to Chemistry with Miss E. Today we are going to quickly cover the idea of figuring out if a bond is ionic or covalent just based off of what it's made of, okay? And what I mean by that is ionic bonds are made up of metals and nonmetals, okay? Another way to word that would be like a cation and an anion, right? Meaning we have charges happening, okay? So ion, right, ionic, you see the root word there, ion means charge. And so metal and a nonmetal. So in order to understand that, though, you need to make sure that you understand the periodic table trend and knowing where the metals and the nonmetals are. So just to quickly recap, your metals are going to be this green area here from the left of the periodic table through the middle, and then below the staircase, and even a little bit of the staircase elements, the metalloid staircase ladder, as we like to call it. And so then your nonmetals are going to be the ones above that. So anything else that's to the right and below of this area, those are your nonmetals, okay? So just based off of the location of the element on the periodic table, as long as you know your metals from your nonmetals, then you have a good idea here to tackle this problem. Covalent, I do want to mention in some states, textbooks, standards, they do call covalent bonds molecular bonds, so just keep that in mind. So those are the exact same thing what I'm referencing here. So if your teacher calls it molecular and I'm calling it covalent, those are the same thing, okay? So covalent bonds are made up of only nonmetals, all right? And so there's no metal in a covalent bond. It's made up of only nonmetals, and this is things like carbon dioxide, right? Sulfur dioxide, things like that, okay, methane. But those are covalent bonds and ionic bonds. So what we're just going to practice here real quick is helping you identify whether a bond, based off of the formula, is ionic or covalent, okay? So let's start with KCl, right? Again, the first thing you need to look at is the first element, because, again, ionic bonds always have a metal, right? They always have a positive cation charge, which are metals, playing that role as the first element listed in the compound. So if I have KCl, I'm going to find where K is on the periodic table, and I see that K is in the metal zone area, so that means I'm working with an ionic bond here. So that one is ionic. Number two, I have Al2O3. Again, looking at that first element, I'm looking at Al. I'm going to find that on the periodic table. Al is aluminum, which is in the metal zone. This is a metal. Think of aluminum foil, right? It's a metal. It's a solid, okay? Definitely not a gas. And so you have aluminum oxide here, and so this one is beginning with a metal as well, so that's going to be ionic, okay? Number three, we have CH4. You can see that we have carbon, so the answer's kind of there. We have carbon, right? And so I'm going to find where that is on the periodic table. Carbon is in the non-metal zone. It actually starts the non-metals on the periodic table. And so carbon is a non-metal, which means I am working with a covalent bond. So you would say covalent or molecular, depending on what your teacher's asking of you. Number four here, you have NaF. I'm going to look at Na and find it on the periodic table, and lo and behold, you do see that Na is a metal, and so it would be an ionic bond, okay? Moving on to number five. This one leveled up a little bit because there are way more capital letters here, which means that there are polyatomics present. Poly means many, right? Atomic means atom. So there's a lot of polyatomics here. There's actually two polyatomics, okay? We have multiple elements existing here. I can't just look at the first element and figure out what it is, because N would be my only element that's first, and N is a nonmetal, which would mean I would pick covalent, but that's not what's happening here. NH4 is ammonium, right? You either need to have these memorized or you're given them, the polyatomics, on a formula page attached to your periodic table. NH4 has a positive charge, nitrate has a negative charge. I have charges happening, which means I have ions, which means I have a cation and an anion, and so this is going to be an ionic bond, okay? All right, moving on to number 6, 7, 8, 9, 10. Pause this real quick. If you're feeling confident in your skills to do this, try those on your own real quick. Pause it and then come back and see how you did. So for number 6, we have CuBr3. Cu is on the periodic table in the transition metal area, so it is a metal, which means I am working with an ionic bond. If I look at number 7, I have nitrogen. Nitrogen is the first element listed. It's bonded with oxygen here. Both nitrogen and oxygen are nonmetals, which means this is a covalent bond. If I look at CO2, I'm going to find carbon on the periodic table. We have worked with carbon in a previous example. Carbon is a nonmetal, and so is oxygen, right? But carbon is a nonmetal, so this is going to be covalent. If I look at XeF5, right, that is xenon is what that is. You have Xe over here. This is a non-metal, and it is with fluorine, who is also a non-metal, and so this is going to be a covalent bond as well. Last but not least, we have Ag3N. I'm going to find Ag on the periodic table. Ag is, as a matter of fact, silver, right? Which is a transition metal, which means it's a metal. And so that means this is an ionic bond. There are other ways also that your teacher might ask you to know the difference between ionic and covalent. That could be by calculating the electronegativity differences. And so that'd be a video for another time. But this is just a very straightforward, based on what's there, understanding fundamentally the difference between an ionic and covalent bond. See you on the next one.